And we're live.
Hey,
Welcome. This is Rob Nisrickfer and WicDev Wizright, and we're going to discuss roadmap.urbit.org, which we've just published. And so this is describing the technical roadmap for Urbit Core Development to get from where we are now to what we think of, what often referred to internally as get it over the hump. So Urbit development won't be done for a very long time. Decades, maybe centuries, but it will be technically capable of sustaining mass adoption way before then, hopefully within the next small number of years. And so Philip wrote up a document which started as an internal memo and then was very tactfully leaked and described a bit about 6 months ago, describing what's needed to get Urbit over the hump. So this roadmap is basically just kind of going into more detail about that. So in this, we got about an hour. We're going to go just describe the roadmap, and then after that, after this hour, we're going to have another video, which is a core dev AMA, and so we're going to have 3 more core devs join us, and we'll take a lot of questions. So we may take a few questions during this time, but mostly we're going to be kind of describing the roadmap itself. So let's go ahead and start. So there, in the introduction on the overview page, you can see what this roadmap is intended to be for. So I'll start by saying what are the goals of the roadmap itself. This is intended to be a living document, meaning we're going to update it frequently. And in particular, we're going to keep it up to date as the set of projects that are being worked on changes. And then also, as milestones get completed, as we come up with new specs for things, as we adjust the specs of existing stuff. So it's intended to be the entry point if you're just, if you're a developer or an investor or someone who's interested in Urbit, and you want to say, what's going on technically, right? What's the status of the system? What are people working on? What are people working on next? And what sort of remains between Urbit as it is now and Urbit being a sort of bulletproof consumer product? So that's what the roadmap is for. And to that end, we broke it up into a number of arcs. So they're high-level goals that all need to be achieved. So I think we'll go through these one by one. I'll list them very quickly, and then we can go into the first one. So the very first one is to raise the kernel and runtime release frequency to weekly. It's much slower than that right now. Develop confidence in security across the board. We have confidence in a few pieces of security out of the many that we need to have confidence in. Manage enough data in the runtime to handle multimedia apps. So right now we can only store 2 gigabytes in the runtime, very soon to increase. But that's not enough for multimedia. The fourth one is approach zero-click maintenance for users. So it should be very easy to keep your ship running, or for a host to keep a large set of ships running. The next one is improve network performance until a ship can handle 100,000 chat subscribers. That number is chosen somewhat arbitrarily, but already ships on the network, when they have large chat rooms, tend to get slow. And that problem will worsen as adoption increases. So we have to scale it. There are 2 more. Make hosting businesses profitable by reducing unit and maintenance costs. So there are currently 2 hosting businesses that exist. There's Tlon and Third Earth, and that I know of. There might be others. And then, so both of them have issues with it costs a lot to run an Urbit right now. And so there are a lot of things we can do to reduce that cost and make it more profitable for them, which generally increases adoption. And then the final one is establish backward compatibility for apps. The long-term goal of this is that there are a couple of them, but basically one is that a developer can write an app once, publish it, and that will keep running forever. And a sort of subset of that goal is that even as we make backward incompatible changes to the kernel in the sense of Kelvin updates, so decreasing the Kelvin version, that the kernel can still run old applications, keep them running. And there's a lot of other stuff in there. So in backward compatibility. So those are the major categories, high-level goals. And so once we achieve all of these at, to roughly these amounts, they're rough, right? But this is just kind of a rubric for how we're thinking about this. Once we hit around these numbers or around these goals, then at that point, core development will not be the major bottleneck for most applications. And that's kind of the one sentence description of what we're trying to do. All right. Well, Philip, anything you want to add there, or should we jump into the first goal?
Yeah, I think that's a good overview.
Cool. All right. So the first goal is raise kernel and runtime release frequency to weekly. So this is actually what we're prioritizing most heavily at the moment internally. Of all the goals, this is the one that we're really focusing on. And that's because we've had some problems with it in the past year or so. But you might actually say that we've always had problems with it, and it's just that those problems are becoming, well, they're both possible to address now, and they're also, we're starting to feel the pain from them more, I would say. So right now, so basically, what we want to get to the point where we can do frequent releases of the kernel and the runtime. So do them once a week, and that means to the broader network, which means that we'll probably be deploying internally much more frequently. Zach Dovson Bornile at Talon just actually wrote up a plan a day or two ago about how we can do this, and so we're going to try doing something like this pretty soon with the release frequency. But I think in practice, basically setting up the internal processes in the team so that we could deploy something weekly. But then I think in practice, then there's still a number of things that make it so that we won't end up doing that for a while. So it's like, okay, we could push out a release this week, but often we won't. And a lot of that has to do with the pace of development, and then especially with basically testing and sort of validating a release. But actually, there are a few things here, right? Actually, so one is that we're going to be scaling the team. So Talon is hiring more core devs, and UF is also hiring more core devs. And so we'll be expanding the size of expanding the number of people working on core infrastructure by quite a bit over the next year or two. That's the plan. And so, having more developers, we should be able to increase the pace of development, or else we're not doing it right. So that's one thing that will increase this pace. Should be a big factor. And then, as we do that, of course, that also requires, scaling up some of the internal processes a bit to make sure that we stay organized, keep like a high assurance for the software that we push out. Actually, there's a good question in the chat. Does a weekly update schedule imply a weekly decrement of the Kelvin version? No, it does not. So a lot of updates are only to vanes, kernel modules. Those do not have a Kelvin version. And so as long as you don't change the public interface to the vanes, which is Kelvin version, then that does not imply a Kelvin bump. So for example, actually there's a PR we're going to release pretty soon that has some fixes to AIMS, but those don't change any of the interface to AIMS. They just fix a couple of bugs. So we're just going to go ahead and push that out, and that won't burn a Kelvin. Yeah, but for things that do burn Kelvins, and this is actually some of the focus at the moment is that when we do burn kelvins, there are a number of things that slow us down when we need to do that. So one big one is that every app developer has to push out a change to their code to say, hey, this app can be built against the new Kelvin, like the standard library at the newer version. So if it doesn't push out that update, then in general the kernel right now the kernel doesn't know how to run old applications, right? Applications that were designed to be run against an old kernel. And so every time we burn a Kelvin, we have to sort of publish the new Kelvin, wait for all that, app devs who we're in contact with to sort of get up to speed, right? Or at least just, wait a while, give them a reasonable amount of time to update their apps, and then we can push it out. Plus, it's not just that, but also when we do that, in order for someone to upgrade to the new kernel, if it's at a new Kelvin, they also have to update their runtime. Because the runtime just has a check in it that says I can't run anything newer than 417 or whatever the latest number is. So there are two ways of addressing the runtime. We'll start with the Kelvin for user space stuff. So there's a project that's being worked on by Tinis Napus and Dinleb Rambep at the foundation. Just started working on that, but it's to add user space shims for old Kelvins, which is basically just some scaffolding so that every time we push out a new Kelvin, we can also add something to Clay and Gall, which are the parts of the kernel that build and run user space code. So we're adding some shims to those parts of the system, some scaffolding there, so that every time we push out a new Kelvin, it's relatively easy, or at least feasible, to add a sort of an emulation layer for the old kernel, so that if we want to add to that emulation layer and say, all right, well, we're lowering from Kelvin 418 to 417, but we're going to keep all the 418 agents running, then it will be at least feasible to do that in some percentage of the cases. Sometimes it's going to be too much work to do that, and so we'll break backward compatibility. And sometimes we actually will want to break back compat in order to, for example, close a security hole, something like that. But getting to the point where it's not incredibly onerous for us to actually support this kind of back compat is one of the priorities at the moment. And then for the second thing, for the runtime, where this problem where if you update Arvo, you'll also have to update var. There are two ways of dealing with that. One is to say, have the protocol negotiation between Arvo and var, so between the kernel and the runtime, have the protocol negotiation be more flexible so that Arvo can go ahead of var. That's one way of dealing with that. But the way we're going to go at the moment is at least the current plan is to instead of building that, we will make it easier for the user to update the runtime. All right, it's easier to update var. So right now that requires going into the terminal, going into the Unix command line, running some commands. So you have to kind of know what you're doing. So ideally, you can do this from Urbit's web interface, where it says, hey, there's a new update to your kernel and to your runtime. Would you like to install it? And all your apps will stay running. So you can just click yes, and it'll go ahead and install it, right? And that will update both Arvo and the runtime. So that's the current plan, is that we're going to build that. So once we have those two things in place, right? Once it's not too hard to build user space shims, so that old apps can stay running, and it requires sort of making it so that it doesn't require technical understanding from a user in order to upgrade their binary, then we can push out Kelvin releases, releases that change the Kelvins, and it won't be such a big problem.
Yeah, the other part about this is, part of the reason why release frequency has slowed is that it's sort of less acceptable now to be pushing out broken releases. For a long time, our strategy was we'll test it kind of as well as we can, push it out, and then fix whatever happens. Which resulted in brief periods of very fast release frequency several times a day to just push out bug fix after hot fix after hot fix. And that's basically become unacceptable. And so over the summer, we instituted a regime of canary moons where we're having people run the releases before they're released to the general public, run them on their real ships ahead of time. And this has helped a lot in terms of the number and severity of bugs that have ended up on the network. It like by its nature, it slows down release a little bit. But what's slowing it down more is not actually those processes. It's more that we're now because we know it's going to go through those processes, and we know that these bugs are more costly when they get out to the main net. We end up having to test things more thoroughly than before, and think through things more thoroughly than before, which is a good, it's a very good stage for us to be going through, and it's encouraging that we are getting there. But we have to get better at this.
Yeah, I agree. So the next item, the next high level goal, is to develop confidence and security across the board. Philip, do you want to describe that one, or you want me to take it?
Yeah, I can take a shot. Cool. Security is a very broad issue. The roadmap document does a good job of talking about different areas of it. The biggest areas are, you can think of them in terms of like what could I do with my Urbit, right? So one area is DDoS attacks, right? How can I be sure that if my Urbit's on the internet, that it's going to stay there, and how expensive is it for an attacker to knock it off the internet? Right. So just like with a website, it costs a certain amount to knock any website off the internet for some period of time. And so what does that look like for Urbit? Another is how many, or can I keep passwords on my Urbit, right? Eventually the answer should be yes. Of course, the answer is no right now. And then there's security around the software supply chain of basically, how do I know that I can install an app? Is that, and once I do, what is that safe from? What is that vulnerable to? Who am I trusting at each point in that? And so each of these are related to each other, right? If you can't, there's a certain level of security that if you don't have, like if any ship is pwnable at any time, then you can't trust the software supply chain because the person who's distributing it, their ship might get pwned. That kind of thing is an issue. And so there's definitely interrelated aspects of these. And yeah, we need to go through and get very serious about each of them.
Yeah, and the short answer is, I would say, to where we are about addressing those is we're in the very early stages of most of them, except for the PKI security. So the security of the actual azimuth contracts, that's been vetted pretty heavily, and those have been live for years now. So the security of those parts of the system is very real. And then there was an audit a year or two ago of the crypto suite that Ames uses, the Urbit's peer-to-peer network. So at least if everything is implemented correctly, which it very well may not be, but if it is, then the crypto system was audited, and there are some minor issues, but it's it's basically sound. And then, for the software supply chain security, Talon has just started sort of ramping up efforts to, do things like limit permissioning to running the infrastructure nodes and making changes to the code on GitHub and that sort of thing. So that's progress is beginning on that, but it's still early stages. All right, I think I can take the next one. Manage enough data in the runtime to handle multimedia apps. So right now, you can only store 2 GB of data in your Urbit. There is actually, as of about a day ago, that might have increased to 4. There's a runtime release that increases this to 4 gigs. That's if not out yet, then on its way out. But that's enough that you can store quite a bit of chat data, right? So for the typical uses of Urbit right now, that generally works. There are some issues with it. Groups 2 actually uses less data, but it uses less memory to store chat information than Groups 1 did, so that should help a little bit. And there are a few other kind of cleanups that we can do to sort of keep general memory use down. But in general, 2 GB is a fairly limiting amount of memory to say this is your whole digital life, right? So in order to make the credible claim that you can store your whole digital life in there, then you need significantly more than 2 GB. So there are basically 2 different approaches to increasing the size of this. One is to switch to a 64-bit interpreter, where you can just very kind of very simply address a lot of information, right? Simply in the sense that each 64-bit slot that points at a piece of data has 64 bits in it, and so that's enough that you can very easily assign an address to all the different parts of your tree and get up to many tens or hundreds of terabytes of data, which of course should be enough for anyone. That's a big project, though, getting to a 64-bit interpreter. And the interpreter, having a memory allocator that is 64-bit, that itself is not necessarily that huge of a project. But doing that in a way that doesn't lose performance is somewhat difficult, because in general, when you switch from 32-bit, which is what we have right now, to 64, then everything is twice as wide, it's twice as spread out, and so you have half as much data in your processor caches. And since being able to since cache locality is one of the often the major bottleneck for most software, that has the potential to slow things down a lot. So just naively switching from 32 to 64-bit could cause a big performance regression. But there are actually a bunch of other things that make this more difficult too. So as soon as you start storing more data in Urbit than you can fit in RAM on whatever machine you're running, then basically we have to do a lot of work to make sure that a lot of different routines that the runtime uses can actually sort of move data between RAM and disk in a way that actually works. And so that means things like taking snapshots and various tools like bar meld, which is the memory deduplicator, bar pack, the defragmenter. A lot of these things, a lot of these routines, if you just naively tried to run them on something with a very big memory arena, they wouldn't work. And so a lot of those need to be redesigned. So instead of jumping straight to 64-bit, what we're going to do is we're going to bump it up from 2 to 4 to 8 to 16 gigs. So right now we're right at 4. There's a PR on GitHub for 8 gigs. And then there's a clear path from 8 to 16 gigs, which is described in the roadmap. That kicks the can pretty far down the road, but it doesn't get us quite to multimedia, or at least you can start using it for multimedia, but it's somewhat limited. And so at that point, we might jump to 64-bit, because once we have 16 gigs, then that's enough that we will have had to address a lot of these issues with storing more data in Urbit than you have available in RAM. Right, so we'll already have had to fix those. So then switching to 64-bit isn't so scary. And then also there's an intermediate point where we could move big atoms to a separate arena. And so you have 16 gigs for the Loom, the standard arena, but you could have 64-bit pointers or some other kind of pointer to another arena for big atoms, which isn't, doesn't let you store sort of general purpose data necessarily, but for multimedia, that's almost always one big atom, meaning like one big number or one big file. And so that might be enough to get us over the edge. So that's an option once we bring it up from 2 to 16 gigs inside the Loom. Then there's another intermediate option that we may take to get past that, to basically add an exception for media. All right. Philip, do you want to add anything to that, or should we go to the next one?
Yeah, I think that covers it.
All right. Do you want to handle approach zero-click maintenance for users?
Sure, I can get that started at least.
Cool.
Yeah, like the way we've always said it is that managing your Urbit should be like managing your phone. You should be deciding what apps are installed and how much resources you're willing to pay for, and that's about it. So what that means is you should be able to generally just leave it and come back to it. And when you come back to it, it should be basically working. It's possible that it's got to ask you some questions like, oh, this app got updated and it wants more permissions, and you might have to approve a few things, but really the same kind of things that you would approve on your phone. And part of getting to that point is just making sure that our releases don't have bugs, so that we don't end up in a situation where we've got to tell people, okay, run this manual command. We do a pretty good job of avoiding that. But there's various other things that go into it. Ted mentioned earlier having the runtime update itself, which is obviously crucial for this. We have issues right now where people run out of memory and have to run meld automatically. There's an app called Ahoy that'll run that for you. Sorry, I think I said
it's pretty cool.
Yeah. So that app will run meld automatically for you from time to time, which is nice. In general, yeah, we need it to be zero click sort of all the way across the stack. There's a nice list of projects actually for all these different things. There's lists of related projects in the roadmap, which give a lot of specifics.
Yeah, one thing I'll touch on here is that a lot of making maintenance easier comes down to just having the thing not break, right? Because a lot of maintenance involves, something went wrong, there was an error, or the thing got into some sort of inconsistent state. And so having the system just work better, right, fewer bugs, is a big part of making it require less maintenance. And so if you look at the project listing, a bunch of those are related to just making sure that the system doesn't have as many bugs.
Yeah.
All right. So the next item here, we've got 3 items left: network performance, hosting costs, and backward compatibility. So I can talk about network performance, so we mean something fairly specific with this. It's basically that one Urbit ship needs to be able to publish data to many other ships. And so, that's like if I'm hosting a chat channel, or if I'm hosting a notebook, right? Like a blog. In that case, I need to be able to publish that to as many subscribers as I want, right? As many people actually want to hear that. So right now, this is the biggest bottleneck to network scaling that we have. There are other potential bottlenecks, but they're much further away. So things like Urbit is a peer-to-peer network with has some routing nodes, where the galaxies currently do all the routing. That really should be the galaxies and the stars that do peer discovery and packet forwarding if you're behind a firewall. And that whole system could be made faster, but actually that's much faster than everything else we've got at the moment. So that could be a scaling issue, but it's not right now. That will happen several years down the road. At the moment, it's this publisher, making publishers be able to distribute data faster. That's the big bottleneck. So there are a few incremental changes that we can make that reduce that bottleneck. And then there's one sort of large arc of non-incremental changes that we can make that get us probably another couple of orders of magnitude of scalability. And so that the non-incremental work has a few names. It's a subscription reform project. It involves the remote scry protocol, which is a network protocol for using Urbit's immutable scry namespace, but actually exposing parts of that namespace over the network so that you can do reads. But that has very nice properties. So because it's all immutable, you never have to do cache invalidation. And that cache can live in the runtime, so you can entirely avoid running knock or doing disk writes on the publisher ship. So that takes a lot of load off the publisher. And then that protocol, in order to be used effectively by user space applications for things like chat and notebooks and distributing source code, that needs to have, it needs to basically expose interfaces, APIs for using that protocol to user space. And that project is called solid state publications, based on the idea of Urbit as a solid state interpreter. By analogy to a solid state drive versus a hard drive, solid state drive has no moving parts. So when people use Urbit's current subscription system in user space, it often feels like it has a lot of moving parts that are hard to keep working correctly. And so we want to replace this with something that feels like it has no moving parts. And making all the data part of the immutable scry namespace is for the first step in that. That's a complex project that involves multiple sub-projects within networking and multiple sub-projects inside of the kernel to provide this interface to applications. And it is being worked on at the moment. Wickrun has a prototype of solid-state publications, actually built in user space and using the current AIMS protocol. So that's being worked on, but it's a long project. It's complicated. And so in the meantime, we'll also do some of these incremental improvements in networking. I would say the first big one there is the project that's called AIMS flow consolidation, or maybe timer consolidation. Yeah, consolidate packet resend timers. And this is a problem of that actually often of a category that often comes up that I call problems of the stop hitting yourself variety. Because one of the big bottlenecks right now on publisher ships is that every 2 minutes they have to send out another packet to every ship that who's ever been subscribed to this chat if they're not online at the moment. And so if for the ship that's running Urbit Community that has something like 10,000 subscribers, every 2 minutes, each one of those subscribers gets a new Arvo event that's a new disk write that sends another packet. So that's actually the vast majority of the disk writes and the events that are happening on that ship are packets to nowhere. And so the first step is basically stop hitting yourself, consolidate those down to maybe one timer every couple of minutes that sends a packet to everybody or something like that to reduce the load on the publisher. And there are a few things like that that we can do with AIMS to improve performance. So we'll do some of those to get incremental improvements in the network performance. And then we'll also be working on different parts of the subscription reform project, both in the kernel and on the networking side, with the goal of basically removing as much technical risk from those projects as early as possible. So that's the general plan.
an important thing to keep in mind here is when you think of network performance, you often think of measuring that in terms of throughput or latency or something like that, and those are important metrics. But another one is definitely the load that it puts on one chip or the other, in other ways, CPU or memory being the normal ones. And so the one of the biggest constraints we have right now is the memory requirements on a publisher's chip. The fact that those scale with the number of subscribers, which is incorrect. That should be constant number of subscribers, and should only be like the network usage, basically, and a little bit of the CPU that scales with the number of subscribers.
Yep, I think it's a good way to think about it. There's a question from Hadzad Walrus in the chat. Do you expect popular or viral content on Urbit to all be served from one ship forever, or gossiped somehow? And maybe we could talk about this in more detail in the AMA later, but I do expect it to be gossiped eventually. So the first version of the remote scribe protocol, it'll all be served from one ship. That'll still be a lot faster than what we have right now, and will, I think, actually be fast enough for quite a while. But then the next step would be to have your star cache scry responses for you, because the star is probably a bigger node, probably has bigger pipes. And then eventually, in it for scaling and also for failover and redundancy, then yeah, I think we will want a form of gossip, and I think that should use scryable data. So basically, it should have we haven't totally nailed this down, but this is how I think about it for now. Is we should have something like a scry resolution system, so that if I look up a piece of data that's in the scry namespace that was published by some ship, well, maybe I should also have something configured, some piece of middleware configured to look for that on some other ship that's republishing it and propagating the signature, so that I can tell that it's the right thing. And then maybe that could even use external systems like IPFS or other sort of data addressing systems potentially. That's a long-term thing. We don't have set plans on.
Yeah. Although notably, it depends a lot on what the content is, but for stuff that's relatively small, like, if it's an image or a blog post or something, like a good rule of thumb is that we would expect an Urbit to be able to handle roughly the load that a regular like website can handle, like as like a personal website, right? That they're just running on some server somewhere. And those in general can take quite a lot. It used to be very common that, when something got posted to Hacker News or Reddit or Slashdot or whatever, then it would go down. That is much less common now, in part due to like Cloudflare and stuff, but also just because everything has gotten better at handling those, like that kind of traffic. And we should get to the point where, yeah, if you make a post that gets popular, you shouldn't have to worry about trying to be like, oh, I need to make this, move this to an enterprise like system, or find some way to spread that out, have other people mirror it. Honestly, one ship should just be able to handle that kind of thing normally, without any real issues.
Yeah, I mean, it's like they used to call that the C10K problem, right? Can you handle 10,000 connections on a single machine? And then that became the C100K problem, and then the C1M problem, and then the C10M problem. And now, there are open source libraries that you can use to get 10 million simultaneous connections on basically a laptop. So the idea that I think that things like gossip end up being more important for redundancy than for actual data fetching, which is usually fast enough, even from a single
Right.
source.
Or if your data is large.
Yeah. Right. Yeah. So it'll be good to have eventually. Hadzad says it sounds great. All right. Hey, glad to hear that. All right, we've got two left, and we've got about 15 minutes. So they're hosting costs and backward compatibility. Philip, What do you think? How do you want to break this up?
I can do either.
All right. Why don't you do backward compatibility? Because I sort of said it from my perspective earlier a little bit in one of the earlier ones. So it'd be good to hear sort of your perspective on that too.
Sure. Do you want to host cost first, or I'm just looking at the order there? All right.
Yeah, okay. I'll do hosting costs first, and then we'll do back compat.
Cool.
Yeah, so for hosting costs, there are, basically it costs a fair amount of money to run Urbits in the cloud. And that makes it hard for hosting companies to be profitable because they're spending too much money to run each Urbit. At the very least, they need to get to the point where running a single, where the marginal cost of adding another ship to their cloud is low enough that the subscription revenue is larger than that, so that when they add more customers, they make more money. So we have to reduce those costs. The biggest single cost involved in running an Urbit is memory use. Urbits are kind of memory hogs, and so reducing the amount of memory that's used for a particular Urbit ship is the biggest impact that we can have on hosting costs in general. There are actually some other ones. So disk use does cost something, and the event log truncation project will make it so that the amount of disk use for an Urbit is essentially constant over time instead of growing linearly over time, which nobody wants, and has become a problem for some people. So event log truncation is one thing, but a lot of this stuff has to do with reducing memory use. So there are different approaches to this. And one of the big things is something called demand paging. So most operating systems do this. And it's basically that, let's say you have some big data set that you need to operate on, and maybe it's 50 gigabytes or something. You can't fit all of that in RAM. And so how do you deal with that? And so there's a system so demand paging means that you page chunks of memory from disk into RAM, but only on demand. So basically only when some piece of code tries to read from that piece of data, that chunk, then that triggers the whole system to pull in that data from disk into RAM, and then pieces of that into the processor. So that's just a feature that has to be built. And there's been some progress on that already within the past few months in Ver. But sort of doing that more and more efficiently over time, and where it can handle sort of more and more data, larger and larger data sets, there's a whole set of things that need to be done on demand paging. And actually, maybe Philip. So I would say the other big thing for hosting, well, there are a couple of big things. One is actually maintenance costs play into this a fair amount too. So all the zero-click maintenance work that makes it so that users don't have to manually, figure out why their Urbit crashed and start it again and run maintenance commands. That also impacts hosting at least as much, because they have to keep these things running. But then the other one is a concept called quiescence. And my understanding is that actually recently there was some progress made on quiescence. But Philip, do you think you could describe that concept?
Yeah. I mean, the easiest way to think about quiescence is if you're not doing anything, don't do anything.
Another stop hitting yourself problem.
Right. It's basically if you're like very, very often your ship isn't really doing anything. It's just kind of sitting there waiting for you to read something from it, or to receive a message from some other ship or something. And the way that everything's built right now, like when people are largely self-hosting ships, we have it where your ship is basically just as active if you're using it as if it's not, just about use the same amount of memory, somewhat less CPU if you're not using it, but it's still kind of constantly hitting the disk, constantly doing all these things. And it's impossible to tell from the outside if it's doing something really important or if it's just every 2 minutes sending, retrying a packet to somebody he hasn't talked to in 6 months. Um, and so you can potentially save a lot in hosting costs, but also just in terms of general, how much resources does Urbit require if you um, are able to recognize when it's not doing anything important and basically put it to sleep, and then have some system of waking it up when something important happens. And so there's a few different ways you can do that. The most naive is just say, okay, if nobody's looked at this ship through HTTP um, in a month,
As in
probably
they haven't logged into their web interface, right? Like they haven't even tried to
right,
use it.
right, then probably it would be okay to turn it off and just turn it on once a day or once every couple days to get updates. For turn it on for a few minutes, um, and then have some trigger so that if they do log in, then it'll turn on, and Urbit's pretty good about turning on and getting back, onto everything within a couple minutes. Even that step will cover a lot of people, especially people who you might imagine might be on a lower tier of hosting, or even like a free trial, like trial is the right word, but like a
Yeah,
freemium plan.
freemium. Yeah.
There's all kinds of models that become a lot more possible if a ship that's not doing very much is very cheap to run. And so that there's a lot of details in how you figure that out, right? Because maybe the ship is actually it's hosting a group, it's hosting a huge group, but the guy never logs into that ship because that's not his main ship. You have to watch for these kinds of things, and so you want to make that kind of thing legible um, to whatever's running the ship in some way or another. There's another more theoretical approach to quiescence, which is more of a sort of spatial quiescence instead of temporal quiescence, which is along the lines of what Ted was talking about with demand paging, which is to say, however much memory your ship is using, if you can make sure that whenever it's not doing very much, it only looks at a small amount of memory, then you don't have to allocate very much RAM because um, it's just not looking at almost all of its memory at any given time. Um, and you can potentially get some good savings from that as well.
Yeah. And things like some of these more, research or um, some of them are more research and some of them are more just sort of not quite immediate changes to the networking also promise uh, to make quiescence easier, because let's say that you're only publishing all your data through remote scry. The host could actually have a big scry cache that it uses for all the ships, and until you log into your ship, you don't have to run it at all. And yet, if somebody wants to, come up to date as a subscriber, they could still do that. So it sort of breaks up the reads and the writes in a way that could be helpful.
Yeah.
All right,
All right.
and I think that brings us to uh, our last item. We've got a few minutes left to talk about
Yeah.
backward compatibility.
Yeah. So, um, backward compatibility encompasses a few different things. Um, the biggest one is backwards compatibility as it relates to the base system, the kernel, and the stuff that's in the base desk. Because many apps, I mean, all apps interact with them in some way, and almost anything that's in the kernel or the base desk is uh, is something where if you change it significantly, you need to make sure that you either that you do one of a few different things. Either you support the old system, um, or you tell people that they need to change, or any of the normal ways of dealing with breaking breaking changes. And so there's a bunch of steps to this. One is in general, try to avoid breaking backwards compatibility at all. There are a small number of things that you'll always have to potentially break backward compatibility. Main one being anything related to security. There's, it might like if there is a security hole, then fixing it by definition breaks backwards compatibility. Um, but there are other areas where it's too costly to really maintain backwards compatibility forever. At least at this stage, and over time, the number of areas like that should go, should reduce in number. But yeah, in the meantime, it's one of the important things we have to do is make it so that when we do breaking changes, everything works cleanly, right? So one way to do that, as Ted mentioned earlier, is to build shims into the kernel so that you can run older code with the same or very similar semantics as before. This is reasonably often possible. It is not always really possible, but it's an important step because it means that we can be more aggressive about making changes because we know that we can do that without breaking everybody's code. Second thing is to rely a lot on version numbers and version negotiation between systems. Which is related to the compatibility shims to some extent. But basically, if you can get really good at handling multiple different versions, at basically specifying what version of an API you're intending to use, and handling multiple different versions of APIs that other people might be using of you, then a lot of this stuff gets much smoother. And that applies both between the kernel, but yeah, so it applies between the kernel and user space. It applies from one kernel to another kernel across the network to another ship, because those are definitely not going to be upgrading in lockstep, right? If one side has remote scry and the other side doesn't have remote scry, they got to be able to talk to each other somehow. And then it also applies between two user space apps, or the same user space app across the network. Those are kind of similar situations. And we should have at least patterns. There are some patterns for this you can see them best in like groups too, for how to use version numbers effectively, that lets you independently upgrade the various sides of it. And to the degree that we can sort of codify those patterns into the kernel, that's also good, because app developers just sort of don't have to worry about as much.
Yeah. A fair amount of work went into developing those patterns and making them work well. And that was a bunch of the Talon user space developers and some help from the kernel team. Yeah, it's something that as a user, you probably don't really see, except for the fact that updates actually go out and don't break everything. And so, yeah, those patterns I think are actually pretty good now. And yes, the next step is basically getting the kernel to understand those patterns in such a way that as a programmer, user space dev, you can kind of write a few migration functions and a couple of definitions, and the kernel will actually handle the protocol negotiation for you to figure out what version of some API your app can speak with apps on some other ship. And that's in the roadmap actually under the subscription versioning project. All right, well, we've got, I think we should start wrapping this up. We've now covered all of the major goals, and I will note that the roadmap is under very active development, and so expect some changes, a bunch of cleanup, a fair amount more metadata, and a bunch more links into GitHub to make it more of a living document and kind of just tighten it up. And so over the next few weeks, expect a bunch more on that, and we'll keep it up to date from there. But yeah, Philip, thanks for joining me here, and we're going to take a few minutes and then go into the next live stream.
Yep, this was good.
Take it easy.